Okay, I think we should be starting. If people are outside, please come in. We're going to start in again with the online groups. If the online people can hear us. Great. So maybe we should go the opposite order now and start from group theme 4. If people are ready to present from group theme 4.
Yeah,
if not. Oh, perfect.
Hi, this is Hallie Berger. I'm from the University of Connecticut. And in our group, we only had 3 participants, so it was kind of a shorter discussion. But we started off by talking about how most of our data is shared in NetCDFs, which may be unfamiliar to some users. So we may consider providing other data forms, such as for GIS users, different layers that they could use in their analyses. And potentially one idea we had was using large language models to translate NetCDF headers into a cover sheet for explaining data. We also talked about maybe directly working with some of the user groups to find out what they would want, such as if they're only interested in seasonal averages, maybe we could use some of that pre-processing for them and provide a climate service versus just giving them the raw data. We had questions about where people are getting their data now, especially non-experts, and the visibility of our data, such as are they just looking through their personal networks and what they've used in the past, or are they actually trying to seek out specific types of data and how accessible is our data to them? Perhaps this would call for making use of platforms that are more accessible and user-friendly. And one example of that is called Ventusky, which has kind of maps of like wind and rain, temperature, and different fields that are very visually pleasing and easy to navigate versus our usual data portals. Also, talking to technical people versus policymakers with influence, there are different levels of expertise in needing to kind of frame our discussions differently depending on who our audience is. For the topic of targeting regions and options for case studies, we didn't really spend too much time on this, but we did talk about combining data sets from different models and platforms and the limitations, especially sharing across different agencies and different countries. So that can be challenging and time consuming, and also kind of a case by case situation, depending on if you're working with a country that is open to sharing data or not. But also we talked about in regional modeling, we're often so focused on the uniqueness of our region, but kind of if we could take a step back and generalize that to extrapolate to other similar areas in the world, and what could we take away from that? For strategies for multiple model nesting, we talked about how there's kind of 2 different ways of doing this. Maybe the most common is starting with the global model and then moving down to smaller regional and even local scales. But there are also cases where upscaling may be necessary. So maybe, for example, looking at pollutant release or a spill, you might look at that in an estuarine model and then kind of scale that up to a larger regional model. We spent some time talking about bias correction and how the user may not understand the nuances of the bias corrections that have been made and kind of what data would be better to use, the raw uncorrected data or the bias corrected, which would depend on their application, of course. And in terms of global models, some may be better tuned to some regions than others. So how could we kind of communicate that nuance to the end user? This would be particularly important if you were doing a multi-model analysis and you had to kind of weigh the scale for some particular regions in a certain model versus others in a different model. Which one would you trust the most? That is a challenge. And kind of also adding and factoring the bias correction on top of that. And then for the last topic, which was the societal drivers, we talked mostly about how we can communicate our complex findings to make them more useful and accessible. And one idea, again, using AI could be to make summarizing visuals, but of course there are ethical concerns about using AI imagery, and perhaps it would be better to find a human graphic designer to fill that space and kind of act as the communicator for you. And these visuals can serve different purposes, such as helping walk through the data. An example we talked about was visualizing a half-meter floodwater and how that would actually look in a real community and sharing that with them. And also responding to lived experiences. So instead of talking about tons of carbon emitted, you could talk about our particular large storm event that was experienced by the community and kind of the impacts that had. We also talked about animations as a potential way of visualizing our results and the need for a lot of back and forth to develop these materials for outreach. We can also make better use of our existing data and serve it in a more personalized way that is designed for the specific end user. In particular, we talked about looking at future projections and making use of the different emissions pathways, so the SSPs and the RCPs, what could happen with future climate mitigation. And there are also ways of looking at maybe predictable pathways with warming and sea level rise, but you could also compare that to dramatic shifts when tipping points are reached, such as ice sheet collapse or AMOC shifts or fisheries stock collapse. Looking at those high impact, low likelihood events could help connect with your audience. And then you could explore more of like what if scenarios or even a game to kind of walk through the different consequences of those different choices and what the future would look like if we choose a decarbonation pathway versus if we continue on our same path. And lastly, we left off on a very interesting point about how there are trade-offs between future climates. We may think that, RCP 8.5 is the most extreme scenario, but if you're coming at it from an offshore wind perspective, perhaps if higher winds were projected in that extreme scenario, that might be more beneficial for what you're interested in. So thinking about the complexity and nuances of the different scenarios. That was all.
Thank you very much. Well, a lot of discussion for such a small group. Thank you very much. I hope you kept all the notes. So we can move to group theme 3, if someone is ready to present.
Hi, Anna. Yes.
Oh, hi, Sarah.
Hi. Yeah. So we were also a small group. There were 3 of us in this session. So we had a rather focused discussion around data rather than about the biogeochemistry and ecosystem modelling as such, but really about collection of data for both monitoring of climate change and also the validation and collaboration of the model. There's quite a lot of information in the Google document. I'm just going to summarize it here. There's quite a lot of discussion around developing regional strategies, and an example being Yemeni Arab regional communications and the building of a regional spatial maritime analysis centre there to encourage more collaboration and innovation. Developing technology and modern geographic information systems, sort of everything underlie and being underlain by the need for cooperation and strategic partnerships, but acknowledging that there can be political difficulties and conflict in the actual collection and distribution of data. One methodology that was proposed as a good thing for getting data that's accessible and used is to actually align the data collection with research work, and then to collect it under what are known as FAIR principles, so that findable, accessible, interoperable and reusable. And under this, there was quite a lot of discussion about the need for local knowledge in knowing what to measure and how to model certain things, learning from the locals or from the indigenous populations, and in such a way you can gain access to information that would otherwise not necessarily be accessible to scientists. There was a point about making sure that your instruments are calibrated and recalibrated, with an example of oxygen sensors that are drifted away from calibration and were showing very erroneous results. And I think a final point that we made was about the need to measure the whole system, not just to measure oxygen or temperature, because your models then become skewed to what observations you have measured and run the risk of becoming less accurate in a whole sense. Yeah, I think that probably sums up most of what we said, but as I said, there's quite a lot more on the Google document, Anna.
Thank you very much, Sarah. I really appreciate that you discussed very different points than the previous session. So that's very useful. Again, thank you very much. I guess that maybe smaller groups work better. Maybe. Okay, let us move to theme 2 then. Thank you, Sarah.
Hi, everyone. So it's me again.
Hello.
So again, we were a small group, three of us. So we basically started talking about the fact that for coastal downscaling, we have different needs regarding resolution, right? So the ones we had talked in the morning, and we talked about possibly defining coastal archetypes to define different needs, like to define, okay, if we have a small islands, we would use this type of forcing, whereas if we have a closed basin, we would need this and that resolution of forcing. So that was one idea. And then we spent quite a bit of time talking about the different downscaling methodologies. So whether we were talking about dynamical, statistical, or hybrid. And in hybrid, we had quite a bit of participation into what would that entail and what were the benefits of doing hybrid downscaling. So we have some examples written in the document in which we talk about what different types of downscaling can be done depending on the use case. So whether to use different like selection of places like clustering, or using an AI model like neural network to learn from high resolution, from a set of scenarios with high resolution modeling, to then use that to better do the projections, or more efficiently do the projections. So going into that topic, we moved into AI as a modeling approach. And that was, I would say, our main discussion. So we talked about how that helped us to deal with a lot of the very slow models that we have. Also, the fact that we have some areas in which we actually do have a gap. So, for example, the 1 to 5 meter area in which we have either very expensive models to do with morphology, or to change of longshore and coast and cross-shore variability. So that is where we could really use AI for that. Also, we have the fact that we need a good bathymetry, and we usually don't talk a lot much about the bathymetry. We kind of discuss a bit about the drawbacks or the challenges regarding AI or the use of black boxes models, right? So we said that it would be important to set some rules like calibration and validation of these models the way you would do with a traditional numerical model. And we also put more in the Google Doc explaining other use cases, like, for example, urban downscaling, where you really need very, very high resolution, or the solving of different processes that currently are not made for climate change projections. So yeah, I think that's a summary of what we did, and you can find more in the Google Doc.
Thank you very much, Adria. I really appreciated that you made an effort to discuss very different topics. And I think AI is a hot topic within the cost predict, so that's very useful. Thank you very much. Let's move to theme 1 now.
Hi. Yeah, I'm just going to summarize what we just discussed in theme 1. Yeah, so first of all, we talked about selection of different CMIP models and different emission pathways. And yeah, the main things to consider, I guess, that we talked about were whether each model is sort of realistic, so the realism of each model, and whether they're available at the right resolution for sort of sensible nesting. And the main thing we concluded was that there's no right answer in that uncertainties can multiply quickly, be that like uncertainties to do with the models themselves, or sort of natural variability within an ensemble if you use an ensemble. So yeah, there's no right answer, and a lot of time it depends on the user. especially with things like considering whether to do sort of high resolution runs up to 2050 or sort of less high resolution runs towards the end of the century. So yeah. Also, having access to CMIP data itself is sort of a big obstacle for some people in certain locations. Yeah, similarly, when thinking about simulation strategy, so transient versus time slice and spin up and bias corrections, again, we ended up concluding that it's sort of finding the right compromise and the best thing for most users. We discussed options for atmospheric downscaling, specifically, and looking at oceans forced with an atmosphere versus using a coupled ocean atmosphere. So forcing an ocean requires a high frequency atmospheric forcing, whereas using a coupled ocean atmosphere, often the frequency of the forcing is a bit less of a problem. So that's another sort of decision to make. We briefly mentioned whether sort of machine learning could be used to help with the coupling between ocean and the atmosphere, potentially in the future. And again, and the just access issues, having access to things like codecs is a really important starting point for people who don't have access. We discussed briefly riverine forcing, so it's very important to lots of coastal areas, not just estuaries. That can have a big sort of geographical impact. So, for example, in Sudan, there are lots of rivers with quite high turbidity that feed into wetlands and mangrove habitats. And we also talked about the sort of challenges with sort of not all rivers being gauged, and also not all rivers have the same sort of nutrients measured, which makes validation complicated, and then projection even more complicated as well. In our group, we were all from quite different areas. So yeah, we ended up talking about whether actually we're all facing the same challenges in all coastal areas. So for example, in Sudan, there's a need to model sort of coastal areas to quite high resolution and to protect marine protected areas from illegal fishing, and also to protect mangroves and study the impact of sea level rise. So all quite similar science questions, but not everyone has the same level of access to models, tools, and data. So things like internet speed can be an issue, and also regional restrictions on what websites and things can be accessed from where. So the cloud computer, or sort of cloud service that we could have would be a solution, but we'd need to have the know-how and training to sort of have users use sort of a course predictor on a cloud. There are also some unique challenges in certain countries around environmental impact assessments and having sort of cohesive organizations that provide good environmental data for that region. And then just a final note, which was that coastal climate downscaling is relatively new. So there's definitely a need for lots of guidance, even amongst the marine community. And so, yeah, that could be quite important as well. And that was it. Thanks.
Thank you very much. And thank you for trying to address all the questions that they were there. I found that impossible. So thank you very much for the input from the online people. So now we're going to move to the people in person. And I'm going to continue with the theme 1 and myself again. Nobody else want to do that. So our discussion, again, didn't focus so much in the questions as they were structured, but we just decided to go and discuss whatever we wanted. So we started from the river forcing, and mostly what we actually call the water and properties that they added to the ocean, not from the atmosphere. So we focused a lot to what we need to have in the rivers. It's not just biogeochemistry that is missing, but it's missing, other things are missing, like, for example, the temperature of this water that is outputted into the ocean. And we focus a lot on the polar environments, which is a totally different story, where we actually have the glacier melting play a key role, and it's very crudely represented in the global climate models. So, for example, melting occurs in the fjords, and how we treat it will have a very big impact on how or where this water will enter the regional ocean and how it's exported into the open ocean. So this will actually make a very big change for the upscaling to the open ocean. We will make it more valuable if we treat it correctly in the regional ocean. We also discussed how the icebergs are mistreated in the models. And if we are to go into very high resolution and smaller scales, we will have to start treating icebergs, parameterize them or represent them into our models better. Then our discussion turned into observations. Of course, we need more observations to be able to validate our models and be able to build statistical and AI models for future projections. In general, we need better synergy between observation, statistical downscaling, and dynamical downscaling, which I guess is one of the main aspirations of the whole cost predict. Then there was some disagreement about the importance of the atmosphere-ocean coupling. So there was some disagreement in terms of what is more important, what is the most important driver for the regional ocean, and what we should aim to capture more accurately, the forcing from the atmosphere at the surface and this coupling between the atmosphere-ocean, or the forcing from the open ocean with the atmosphere acting as a secondary thing. And of course, there is no correct answer, and really depends on the region that we are considering and the question. Like, for example, winds and precipitation evaporation are key for regions of convection. And also this relates to an argument that we have about should we use time slices or a continuous approach. So time slices may be more appropriate for applications with a couple regional atmosphere-ocean system that involves phenomena that in nature operate in shorter time scales, like still involving climate change, but faster pacing phenomena. While for regions influenced from the open ocean and from processes operating on very long time scales and decadal time scales, the continuous simulations may be necessary in order to be able to understand and be able to separate the nature of variability from the climate change. Then we all agree that we need an intermediate state, an intermediate model that has, that it may be a global ocean model or a basin length ocean model or a wide region ocean model, but it has high resolution and also solve processes that are missing from the CMIP, and then will be used to force a regional self-seize model. Data storage is a big problem that we have. Of course, we're going to have high resolution models, a lot of projections and samples. Where are we going to store this data? And maybe we discussed that maybe there can be a strategy, a mixed strategy, where we're storing some of the data and we use some of restarts where we can generate data as we go and as requested. And the strategy will depend if it's more expensive to store this data or it's more expensive to run the model from the restart. The metadata are the most important part here for the end users. They need to be, the metadata need to be informative, consistent, and transparent. And we understand that, like, for example, I'm an ocean modeler, and it takes effort to make the output so with a good metadata. But if we start applying this practice now, it will pay in the long term. And finally, we actually had some ECOPS, early career ocean professional discussion, where we said that we need more training workshop for capacity building, and maybe Cost Predict should start aiming to have more training workshop. And in the end, it's the ECOPS that will retain everything long term. And we felt that there may be sometimes some miscommunication between the very early career scientists and the more senior scientists. So we may need some intermediaries to bring that together. And I'm going to stop here, and we can continue for theme 2. Theme 2?
Thank you. So, well, in our group, there were less people than expected. Somebody ran away, probably. Yeah. And yes, we didn't add too much to the discussion made in the morning, where, however, we touched more or less all the suggested points. concerning protocols for forcing data and nests, it was highlighted that online nesting in downscaling, that means two-way nesting from large to small domains, is useful, but it's computationally expensive. So this could be a kind of constraint in some situations. Then it was highlighted again the need of interdisciplinary interactions, especially for understanding well the impacts. So in particular, there is the need to find the right resolution in the modeling chains for addressing engineering purposes. From this point of view, if we go really in the very end of the modeling chain, and for example, we would like to address accurately, for example, urban floods, we should know many specific elements and aspects of urban planning and urban features, including, for example, sewer systems. And concerning this, concerning downscaling, it was highlighted again that there is a kind of gray area concerning the lack of understanding about how you force high-frequency models starting from global models. There was a need for a kind of, let's say, organic comprehensive organization of these methods. And then in the very end, we were completing our discussion a little bit in advance, but we stayed for another 5-10 minutes with a discussion about data observations by which the models can be validated. So indirectly, the issue about, let's say, building confidence, as we said in the paper that mentioned John this morning, is an important issue, and we need more and more data sets for model calibration. Concerning bias correction strategy, we agreed that it is often unavoidable, and it is preferred to be made after the run of the coupled projections. And then again, also the same, let's say, concept of this morning emerged concerning machine learning, that currently is most useful for, let's say, calibration purposes, to help in calibrating the models. That's all. Okay.
Thank you very much, Alfonso. So Yuri, are you reporting for?
So we got the same problem with numbers, but it was very lively discussion anyway. And free-floating discussion, but gathered across the different points. So about the simulation strategies, we definitely had quite a relatively common agreement that transient is the way to go because of all the non-linearity. But we perfectly aware that when we go down to much higher resolution local model, transient might not be an option for computational constraint, and therefore in those situations, time slices inserted in a kind of a temporal nested approach could be a way to go. About the spin-up, there are definitely two different angles on that. One is the spin-up for the pelagic environment that is very much dependent on the nature of the basin, depending if it's enclosed or semi-enclosed or very open regional sea. But the other problem is especially for models that have let's say some representation of the benthic dynamics that is not simply like a bucket of stuff that comes in and goes out after a certain point. And in that, for those models that have a benthic representation, that you might need to have a much longer time, and so we will need to develop some protocols to then try to shorten this, because that might not become then to avoid the computational constraint there. And there are some example on spinning up on 1D water column models to then shorten that time of spin up. Another thing that could help in reducing the spin up is having access also to either higher frequency product from CMIP or variable that are not part of the standard protocol, but that the model actually generate anyway. And so having access to those extra variables, for instance, might also be useful. And something that, and similarly here, more for boundary condition rather than spin up, because CMIP tend to have, or at least definitely CMIP 5 for sure, and some could be similar for CMIP 6. I haven't looked in detail yet. The high frequency, and where high frequency I mean monthly, at 3D is not for ocean biogeochemistry is not always available, and so and while we as a regional modeler we would definitely need that. So to try to meet halfway through, it could be that if we could define some common region where they could save higher frequency only around those boundary, and then we could nest a series of regional downscale model starting from those common region. In terms of protocols for data and missing variable, especially, one thing was that we believe that that's definitely an area where machine learning could help in trying to infer relationship between those missing variable and the variable that are available within CMIP, for instance. So then we can reconstruct afterward the missing variable, and so here is, and we could infer that both from observational based product like Water Ocean Atlas, satellite, and this type of product, as well as the CMIP model themselves. One suggestion was, for instance, how if you look at the relationship between, for instance, nitrogen and phosphorus, or nitrogen and phytoplankton among the different CMIP models, can how similar or how different they are, and so if they are similar, then can we use that relationship to cover the missing variable? Another thing about protocol, and especially about forcing, is we often look at forcing as atmospheric forcing and climate forcing, but when we talk about biogeochemical and ecosystem, then there is a lot of other anthropogenic forcing that we might want or not, and there was a discussion if this is something that we want to cover, so like river biogeochemistry change, so eutrophication, but can be trolling, can be MPAs, can be and the list can quickly start increasing. So where do we want to put the boundary, if we want to put a boundary on what we want to consider? Because, and going to a new point in a way, a lot of the discussion that I've seen between the two sessions was covering mostly the biogeochemical side rather than the ecosystem side. But then, especially when we go to ecosystem level and higher trophic level and habitat, then again, the topics and the potential problem that we want to address increase significantly. And so, can we really define like a common protocol when the questions are really that different? And so, and this was picking up on what Anna was saying, reporting on the first period, on the first session, on understanding what we can include in a common protocol and what we might want to address with a type of decision metrics. And so say, if your interests are this, and that, then these are the suggestion in a way. And finally, similar with this tension, there is also a tension that was highlighted, that because of the computational constraint, because of the human constraint of how much time we can and how much resources we have to address this problem, there is a tension between trying to avoid duplication of work. And so if people are working in the same region, they might actually co-produce the projection for the downscale projection for those areas. But at the same time, we have to be careful that in optimizing the resources and so in co-producing those projections, we're not losing information that a multimodal ensemble can actually provide on those areas. So there is a balance there. No silver bullet, and probably not saying anything particularly new, but it's definitely worth highlighting this. None of this is in the Google Docs, but I promise that I will write that.
Jason? Yes.
Okay. Thanks, Anna. Okay, well, we actually had quite a few people stay to join theme 4 right to the bitter end. We focused on actually went back to the questions we were asked and focused on those reasonably well. So starting off, we talked about data and actually acknowledging this is one of the big challenges, accessing data, and actually including the practicalities of moving data about and transmission of data is still a real problem. We're a long way from fair principles of data in the modeling space, and so we would really want to see if we can get to kind of findable, accessible, interoperable, reproducible? No, what's our reusable? Yeah. The principles in data, and I think this is even true for global models. You know, it's not as if we're unique in the regional community for this. So identifying examples of best practice of data handling in this space and seeing what we can follow in that, I think would be really good. Then we moved on to the need for tools to visualize and analyze the data, and we're talking particularly about here the translation process between raw model data and what users might want. So things like decision support tools, and the rather exciting suggestion of actually building artificial intelligence agents who would do that translation. So that rather than every set of translation from raw data to climate services product was done on a case-by-case basis, you had an artificial intelligence system that would do that all for you. How you designed that and how you would be able to properly interrogate it, I think, is left to the imagination at this stage. So then the link to ocean literacy itself was seen as really important in terms of the information we provide and developing confidence, in our language of describing uncertainty, or confidence as well as uncertainty, and then relating what we are providing. We tend to provide things in terms of probabilistic understanding, but maybe things in more experiential understanding. So relating things to kind of past experiences of different communities, I think, is actually quite a powerful way of communication. But to do that, we then have to capture the local knowledge that exists in communities around the world relating to this, and actually then making that relationship between the climate information and local knowledge, I think is really key. And then actually considering how the message of our projected impacts would affect local people, I think, is really important, and then that probably brings in behavioral science and potentially even things like arts as well, because potentially we may be making projections of the future that would have quite substantial impacts on people's lives and livelihoods, and so we should think about how the communication of that impact is done proper and sensitive way. We then moved on to talk about regions, and acknowledge that in Flame, the fact that we want to go from the regional all the way down to the local scale, I think is really important and unique, and not something that we would want to lose in our definitions of the region. So a kind of a counter example of what we do is possibly the Cordex program, where they chop the world up into some big boxes and say these are our regions, whereas actually, you know, we could chop the world up into 10,000 little boxes and say these are our regions, but most of them will probably be unpopulated. So that's probably somewhere in between, basically. And there's quite a lot of discussion on how we would define those, but I think it kind of boils down to a combination of case studies with lots of data and lots of regional models. So imagine, you know, the Baltic Sea, for example, you'd have 100 different regional models and lots of data, and you know, some other regions with no data and no models that then kind of a challenge for people to go and say, actually, you know, go to this region and do downscaling. And then kind of stepping back, scenarios that have local elements in them as well. So it's not just all about the large scale drivers, but also local drivers like land use change and adaptation scenarios, and how things get mitigated. And then finally, we touched on societal drivers. We noted that we hadn't actually talked about human health as a societal driver in all of this, and we should probably, you know, make sure we do keep that folded in. And by human health, I'm kind of thinking of all, you know, physical, medical, mental health, all aspects of it can be impacted by marine climate change. So keep that all in play. And another thing that's quite important in Flame is actually that we have the multiple societal drivers working in concert in a way that is quite difficult. So we are looking at people interested in flooding and coastal hazards on one hand and kind of marine ecosystems on the other. In practice, people will tend to focus on their own discipline, but I think having those, you know, disparate communities in the same room is in itself very important. And then this kind of circles back to the interoperability of data, actually making sure that the outputs of this diverse modeling approaches then become usable together. And it will probably be the Frankenstein model that Lucy referred to. I don't think we can really avoid that, but we can make it as least Frankensteinish as possible by kind of putting these bits together. And then I think that's probably everything we did, unless I've missed anything. Yeah. Brilliant.
So I can see that you're all, thank you, Jason. I can see that you're all very tired, but we're supposed to close with a half an hour discussion. It doesn't have to be half an hour. It can be as long as you want it, but this is more an open discussion. So if you want to address something, if you want to discuss something, now it's the time to raise it. And to start with me, because you mentioned about the operability of data. And for me, based on the discussions that we have, it made me realize that I now have even more questions that I have answered for some aspects. And we may not be able to address everything, but at least we should start from somewhere, which is very important. And we can refine it as we go in the future. So any discussions, any questions, something that you would like to highlight from the audience? Jason, any thoughts from you? Okay, I can see that. Oh.
So what happens now? We have this, you know, we had this paper, right? And we have this great discussion and workshop today. And what are you all thinking about in terms of the next steps for Flame, right?
Do you want me to start, or do you want? You can answer, and then I can add my thoughts.
Yeah. I mean, I think that is a big question. I mean, I think that the first thing is to digest what we've talked about today, and that will take a little bit of thinking. But I think beyond that is moving to a process where we can get some details onto some protocols, and so that we can actually do some examples. I think probably the process for that is to develop a set of working groups. I think that can meet offline or meet online rather, but not in plenary, and to actually get down to what are the actual, actually make some practical decisions about this, and define, threads of the global coastal ocean modeling into comparison program, basically get it set up. I think this is going to need a little bit of online presence as well, so a place for sharing information and actually describing these protocols that people can interact with. So I think we need to do a little bit of a design phase on that. I mean, I can possibly picture a little bit about what it looks like, but I'm not. But I think that level of practicality is what needs to happen next, and I think we're probably talking a little while for that. So I think we had some. Were those responses to that, Joanna, and then Alex?
Well, we discussed that during our breakout group. So of course, we will continue this discussion, but as long as it is only just discussion with the meeting, then we don't see much the added value. So we discussed that maybe we can end up with a kind of a document fit for purpose or recommendations similar to what has been done, for example, for some other programs. So we had it in G2, so that will bring a kind of a motivation of the working groups, not just discussing, putting minutes and then continuing again discussing. It should be very structured. We are all aware the topic is very complex. It encompasses everything, and longer we discuss, more complex and more element will bring. But at least we have to end up with something on the design phase to have it as a paper to continue further. And now I give you the microphone to you.
Thank you. I completely agree. I think we have to get something to start. And one of the things that we kind of should start thinking is which are going to be the pilot sites where we are going to start doing this downscaling somehow. Obviously, you have several that the European community is already doing, but it's the rest of the world that we are not doing. We are starting and we are struggling into doing it, and it's probably looking into it and looking at how we can generate a program that we can generate funds somewhere to do it.
Do we do on the pilot science and on the methodology? Of course, we will have pilot science as showcase, but we also do it as overall methodology that will be transferable and allocatable to be as much inclusive as possible. And maybe based on that, we can also make pilot size as examples. Not to, otherwise, there's a risk we won't be inclusive, or then you can think as chairs of more creative format.
That's work, yeah. So I definitely agree. First of all, we need to start creating documents, the protocol, and I think that was how I discussed in the introduction. That's the idea, that we meet here, we get the feedback, how the community see things, and then we form work groups, as Jason mentioned, to actually start fleshing out and drafting the protocol. Then, and this will involve some details that not everybody cares to discuss. It's going to be groups of specialists. And then when we have this draft of the protocol, it can be shared with the community. About the pilot side, so the problem here is that all this is done with no direct funding in reality. So we're gonna have we're gonna first create a protocol that everybody could in theory participate from around the world, and this is the guideline that we give. And the next step will be to have maybe pilot sites once there will be some funding for that or some appetite for that, I think. Jason?
Hi. Just to get back one step regarding the structure of Flame, and since you will be, or you are already one of the chairs of COSTT, one of the things that we can do in the meantime is to have another branch of COSTT where the long-term projections will be part of COSTT, because then Flame can take advantage of this long-term already established community. that could be one way to go.
Yeah. This doesn't work. Okay, it works. I think that we need collaboration among the different communities too. And we have been in discussions with Flame and Cliver, which is kind of the equivalent, not Flame, sorry, for Cortex and Cliver, which is kind of the equivalent for the atmosphere and for the open ocean. So we definitely need collaboration and take advantage of what other people have done, designing these protocols in order to set out our protocol. Jason, do you want to add? I have a question online, sorry. It just takes 3 seconds when I switch it on.
Yes.
Yes, can you say your question? We can hear you.
Yes, thank you very much. My name is Mohammed Humran. I am interested in regional maritime management. My question is, we are living in maritime environment that affected by many factors, local, regional, and international. So Red Sea, Arabian Sea, and Gulf of Eden, there are one of the dynamic maritime and they affected by many problems. So how can we, you are lucky and you have been advancing in modern technology that help you to get new and daily maritime data and information. So how can we get advantage in like Yemen and Arabian and regional maritime research center from European and US maritime center that could help us together to protect the environment, the maritime environment basically. Thank you very much.
Sorry, so the question is how we can bring all the knowledge together that we have maybe from, that already exists, maybe in regions like the Arabian Sea and to address the problems that we're trying to address.
Yes, how can we enhance international, regional maritime management to solve the issue that we have been facing and they affected for all of us?
Yeah, I think that's a very broad question and probably broader than Flame can address, but it might be one for the coast, the whole Coast Predict community, I suspect.
Yes, I agree. I think that to address the whole marine, like the environment as a whole, not just the climate projections, but what is happening now and maybe any anthropogenic activity, we're going to need Nadia's vision, the global cause, the global cause, which essentially will bring together observations, what is available in terms of observations, short-term forecast, real-time forecast, and long-term projections, and even like design pilot sites where we have new observations and establish all these things that Nadia want to establish. So this is not something that Flame can address by itself, but hopefully it's something that Coast Predict as a whole, with the whole core projects and other new projects that come like Focus can address, I think. I hope we answer your question. Are there any other questions online? Any other questions in person? So I guess we can conclude early if you don't have any other things that you want to discuss, but we're going to take a photo. And so the people that persisted and lasted to the end, they're going to